Hello students, my name is Atul, Faculty of Physics at Akash Institute. In our previous video, I had told you about the static electricity and the methods of charging. We had also done some experiment with the static electricity. In this video, I am going to tell you about the Venn digraph generator. A Venn digraph generator is a device that is designed to create static electricity. The American physicist Robert Jamison Venn digraph invented the Venn digraph generator in 1931. The device that bears his name has the ability to produce extremely high voltages as high as 20,000 volt. Compared to the normal house voltage, that's a lot. But before starting with some fun experiment with Venn digraph, let's first understand the basic principle and working of the Venn digraph. A rubber belt moving above two rollers, one of which is surrounded by a hollow metal sphere. The rubber of the belt will become negatively charged while the upper dome will become positively charged. It is just like rubbing balloons on my hair or rubbing PVC pipe with woolen cloth, where I transfer charge from my hair to a balloon where one body becomes negatively charged and the other one becomes positively charged. Now back to the experiments. If I put some metal pens on the top of the Venn digraph generator, it should take over the same positive charge as the sphere because it is conductive. And we know like charges repel. So when I turn this on, the pen should fly off. Now what would happen if I put paper bits on the top of the generator? But before trying, what according to you will happen? Paper bits is an insulator, so there is a possibility that nothing will happen, as there is no way you can pass charge on it, right? Let's see. Oh, wow! But how can we explain this repulsion between the paper bits? As insulator don't conduct electricity, so how can you charge them? Well, the answer is quite easy. These paper are insulator, but not a perfect insulator. Air is usually an insulator too. But how can we explain this? When the Venn digraph generator is turned on, it builds up a ton of static charge, that is, a bunch of positive charges on the outside of this metal sphere. So that when I bring this smaller grounded metal sphere close to it, it discharges through the giant metal. As the large ball charges, the electric field eventually becomes large enough to cause dielectric breakdown of the air. The nuclei of the atom in the air are pulled in the direction of the electric field, while the electrons are pulled in the opposite direction. When the electric field is large enough, some of the electrons are pulled completely off their atoms. This is the reason why we get electric shocks, especially in winters. When you get out of the car or when you touch a gate handle, you feel a shock. The cause is almost invariably due to sudden discharge of static electricity. Hope you like and learn from the video. Thank you for watching. See you in next video.